Hello everyone, welcome to Math World. This video is to discuss functions, which is from paper 1. Now, let's start with the notes first. Basically, if let's say you are given this form, f(x) approaches y, so I can easily change this into y equals to fx. Okay, so in this chapter, you need to know the domain. Alright, so for your information, domain of f is denoted by d. And since this is a function of f, therefore you just write a subscript of f. Now this domain of f is referring to set of x values. Okay, and another term that you need to know from this chapter is range of the function. So range is denoted by r. Then rf, this is a set of y values. Okay, so these are the two basic terms, domain and range. Now, the next part that we are going to discuss in this function chapter is inverse function. So, if your function is fx, alright, the second part, the inverse function notation is going to be f power -1. This is our inverse function. Okay, so now the conditions for the existence of inverse function is the fx must be one-to-one mapping, or fx must be one-to-one function, or probably fx has one-to-one mapping. Okay, or fx is one-to-one function. Okay, then the method to get the inverse function, so we have two methods here. Alright, so the first one is let y equals to fx, and then we rearrange it so that the x is the subject. So x as the subject. Once you get the x as a subject, we will change the x into f inverse. Okay, then the x will be changed to f inverse, and then the y over here will be changed to x. Alright, so there's the first method. The second method is you can just use a composite function. So f of f inverse equals to x. This is the composite function. Alright, so you have two methods here. So from the inverse function, we have important parts. Alright, so now we know that for the mapping, because it's mentioned that the f inverse exists when function the fx has one-to-one mapping. So one-to-one mapping, now one x maps to one y. So let's say this is the f. We always maps the x to the y. Okay, so just now I started with set of x values is referring to is called domain. Alright, the set of y values is called as range. So now your f maps x into y. Therefore, this is domain f and maps into range of f. And now for the f inverse is basically opposite direction. So this is my f inverse. So all functions must map the domain into range. That means here it's going to be domain f inverse and range f inverse. So when you look at this mapping diagram, I will have two formulas. The first one is right in this group. Domain f equals to range f inverse. And in the second group, I will get range f equals to domain f inverse. So these two are the important formulas for us to identify the inverse function together with the domain and range for the inverse functions. Okay, on top of this, you are requested to know how to sketch a graph of y equals to f inverse. Alright, so basically the graph of y equals to f inverse is the reflection of the original graph y equals fx in the line y equals to x. Okay, so that is the method to sketch an inverse graph. Now, just now I did mention that we have composite function. So what is composite function? So the third part that you need to know from this chapter is composite function. Okay, so composite functions, the notation will be this small circle. So you will see this in the book, and we normally write f of bracket gx or fg bracket x. Okay, f bracket gx. So this is the composite function. Right? We will always use the second form instead of the first form. So now this means given fx and gx, alright, f of gx, this means, okay, we plug gx into fx. Okay, initially it was fx here, fx. So now this is your new x. That means we plug the gx into the fx. This is how we get the composite function. But you need to take note that for composite functions, okay, the existence of composite functions is restricted to this rule. So f gx, right, exists when, because we plug the g into the f, right? So the range of the g will be the x in the f, which means it's a domain. So when whole range of g is included in the df. Okay, it must be whole. It means that everything belongs to range of g must be included in the domain f, which means, right, range of g is a subset of domain f. Then your composite function exists. Otherwise, the composite function does not exist. Okay, so this is the existence rule for the composite function. And at the same time, okay, so we can find out the inverse function for composite. So let's say you need to find inverse of fg. Okay, so I can say that this is same as, instead of finding the fg first, this is first, then you find the inverse, I can just direct refer to their inverses. That means it's same as g inverse is a composite function of g inverse f inverse. Okay, so this is another formula. And this is the relationship between inverse and the composite function. Alright, so that's all for the notes for this video. So let's move on to the question. Now, first question, given the function h is defined as a quadratic function whereby the x is real number and x less equals to m. Okay, the r here means real numbers. So express hx in the form of a bracket x plus p squared plus q, where a, p, q are constants. Okay, now b, state the range of hx. C, given hx is a one-to-one function, state the m value. And then d, with the m value, express or find an expression for h inverse and state its domain. Okay, so first of all, you have to express the hx in the form that is completed square form. Alright, so that means we have to get that form using completing the square method. So completing the square method, you must make sure the coefficient for x squared is positive 1. This can be done by factorizing positive 3, the coefficient for x squared here, which means I will be getting x squared minus 3x. and then plus 11, just leave it outside. And then now from here, okay, rewrite the first two terms. If we do it step by step, plus square of the half of the coefficient of x. So the coefficient for x is actually negative 3. So now half of this, it will be negative 3 over 2. Alright? And then combine the first and third term. First and third term. So factorize the square outside the bracket. Put it outside the bracket. Now write down the remaining terms. So the remaining terms will be x and this minus 3 over 2. So I will be getting x minus 3 over 2. Then minus square of minus 3 over 2 is 9 over 4. And then plus 11. And then from here, when you do expansion, okay, so just multiply. I will be getting 3 brackets x minus 3 over 2 squared. So minus 9 over 4 times 3 plus 11, that is going to be plus 17 over 4. Okay, so when you refer to the question, we have done the form. Alright? And now I can just write down my APQ. My A is 3. My P is negative 3 over 2. And then my Q is 17 over 4. Okay, so done for the A. Now B, state the range of Hx. So B, from this completed square form, we are going to get minimum point. Okay, how do I know it is minimum? Look at the coefficient for x squared. This is positive. So when positive, you will be getting a minimum point. So then now, what are the coordinates? So you just let this be 0. So when x minus 3 over 2 be 0, your x will be 3 over 2. And then this 17 over 4, the plus 17 over 4 will be your y coordinate of the minimum point. So which means now here I will be getting 3 over 2 and 17 over 4. Okay, so now look at the x here, the domain. X is less than equals to m. Alright, so which means if I sketch a graph, right, I will be getting this point. This point with coordinates 3 over 2, 17 over 4. So this is my y value. So which means my smallest y is this value. So the rest of the y will be greater than that. So I will write my range of h. Okay, remember the range means the y values. So it will be hx. Okay, now look at here. Your x less equals to m. Alright, there is an equal sign. That means it will be equal sign for the y value as well. So minimum is 17 over 4. It could be more than that based on the graph. So that's all for the part B, range of h. Now C, given hx is 1, function, state the m. Okay, 1, function means, right, let's say I refer back to this graph. 1-to-1 function means that you will only get one intersection point when you draw a horizontal line, which is parallel to x-axis. So this happens when, right, I will either use this part, this is my graph, or this part. Okay, that means it depends on your domain. So now since your domain x less equals to m, that means now I will say that my x, this is my x, equals to m. Alright, so less equals to means towards the left side. So I will say my c, m will be equals to 3 over 2. Okay, because if I consider the orange color, the orange part, and when I draw a horizontal line, there's only one intersection point. So I will just accept this biggest m. So therefore, this is my m value. And the question says state. That's the reason. Okay, without any calculation, we get the answer. Now D, with this m value, get the expression for h inverse and state the domain. So now, to get the h inverse, we need to refer to the completed square form. So my D, hx equals to, I just copy down this, complete the square form. So it will be 3 bracket x minus 3 over 2 squared plus 17 over 4. Let it be y. Let y equals to hx. Which means now, okay, I'm going to use the first method to get the inverse function. Because the second method involves the composite function. Now get the x as a subject. So which means now here you just need to move this term, this constant to the left side. Then I will be getting y minus 17 over 4 equals to 3 bracket x minus 3 over 2 squared. And now get the x as a subject by moving down the 3 first. So it becomes 1 over 3. Okay, and then now you can get the same denominator for the left hand side. So I make it to over 12 because of the 4 here. So which means the y becomes 4y, then minus 17 equals to x minus 3 over 2 bracket squared. Now, to get the x as a subject, we need to eliminate the square. So this square you move to the other side, it becomes plus minus square root. So I will get x minus 3 over 2 equals to plus minus square root 4y minus 17 over 12. Okay, and then get the x as a subject by moving the minus 3 over 2 to the other side. It becomes positive 3 over 2. Now, we cannot accept both plus and minus, so I'll leave it first. Later, I will decide whether we choose a plus sign or minus sign. So here, 4x minus 17 over 12. And you change the x into f inverse. Then the y on the right side, sorry, this is y, not x. Okay, the y on the right side will be replaced by x. Okay, how do we know this is plus or minus sign? The question mark. Now, for your information, this whole expression will be giving you the f inverse. That means the y value of the f inverse. So we know that range of f inverse equals to domain f. Okay, go back to your function. So your f is this, and this is your domain. And just now we have found the m is basically 3 over 2, which means now your domain f is x less equals to 3 over 2. So here I will write my domain f is x less equals to 3 over 2, which means my range f inverse is going to be f inverse. No, this is not f, this is h. Okay, so I change. Okay, h. So here h inverse of h inverse, it will be less equals to 3 over 2. When h inverse less equals to 3 over 2, that means the maximum is 3 over 2. So therefore, this must be minus. Because when you replace the x by any other numbers, this square root will be minimum value of 0. So it could be more than 0. So when you put plus, it will be greater than 3 over 2. Okay, so this is our f inverse. And according to the question, other than the function, we also need to state the domain. Now, the domain for h inverse, okay, so let's see. Domain for h inverse is basically range of h. Alright, we have found the range of h just now. This is a range. So what to do is we just copy this result and replace the hx by x because the domain is x, sets of x values. So here I will write x greater equals to 17 over 4. So that's all for this question D. Right, next question, number 2. Given fx, state the possible domain for which f is defined. B, state the range, then show that f has an inverse. D, find the inverse and the domain of f inverse. And then you will have G, state the A, find the composite function, and state the reason why, whether the composite function f(gx) exists or not. Okay, so it's a long question over here. So let's start with A, my fx square root x minus 4 plus 2. Now, to get the domain, remember the domain is referring to the x set of x values for which function f is defined. So our x is inside the square root. So we know that since square root of x minus 4 is greater or equal to 0, that means, right, so x minus 4 must be at least 0 because square root of 0 is 0. So x minus 4 must be at least 0. Hence, my x must be at least 4. Okay, so this will be my domain. So domain f, x greater or equal to 4, whereby the x is real number. So done for the A. Now B, state the range of f. So now, refer to this function, your fx equals to square root x minus 4 plus 2. So since square root x minus 4 at least 0 for all x values, that means minimum is 0 for the square root, then I will say that my fx, it will be at least 0 plus 2. That means your fx is going to be at least 2 when the x is real number. So this will be my range. Okay, done for the B. Now C, show that f has an inverse. So what to do is we sketch a graph. Okay, so we sketch this function. Now, basically, if you refer to y equals to square root x, your graph is this. This is your y equals to square root x. So x minus 4 means that it is a translation. Right? Translation is in the next video. So translation of 4 units to the right side because x minus 4. So what I need to do here is, okay, so I will write square root x change to square root of x minus 4. This is translation. X is 4, y is 0. Then after that, square root of x minus 4 plus 2. This is translation again. So this is again translation. 0, 2. So it means that you move up the whole graph by 2 units. Right? So just for information, when I move up, let's say this is the first, this is the second. So I move it to 4 to the right side. This is my y equals to square root of x minus 4. Then I move up the whole graph. I move up the whole graph by 2 units. That means here I will be getting, instead of touching at the x-axis, now touching at 2. Okay, so touching at 2, still 4 here. So my point has been moved up. This is my graph. Okay, so once you sketch a graph, you just draw a horizontal line. Shows that there is only one intersection point. So from here, you just write based on the horizontal line test. Okay, there is only one intersection point. Hence, fx has 1-to-1 mapping, or fx is 1-to-1 function, up to you. Okay, so when it has 1-to-1 mapping, therefore f has an inverse. Okay, so this is how we solve the part C. Okay, now D, find f inverse and state the domain. So now for D, your fx is square root x minus 4 plus 2. So again, when you need to find the f inverse, what to do is just let y equals to fx and get the x as a subject instead of y. So y equals to square root x minus 4 plus 2. So move the plus 2 to the other side. That means y minus 2 is square root of x minus 4. And then you square both sides. To eliminate the square root, we need to square both sides. So which means now here I will be getting x minus 2 squared equals to x minus 4. Hence my x is going to be, just move this minus 4 to the other side, 4 plus x minus 2 squared. Okay, and change the x into f inverse and change the, oh wait, mistake over here, this is y, not x. Okay, and change the y into x. So this is my f inverse. And now the question is also asking for domain for f inverse. So now we know that domain f inverse equals to range of f. Now range of f, very simple. Okay, you go back to the question over here. Alright, possible domain, which means the x can be, now range of f already found. Okay here. Critical equals to 2. So I will just write range of f, fx, critical equals to 2. Therefore, domain for f inverse, just change this into x and rewrite the rest. So here it will be x critical equals to 2. That will be the solution for D. Now given the G, state the A. Okay, so next part. Given the G, which is 4 over 2x minus 7, x is not A. 4 over 2x minus 7, x is real number, but x is not A. And now you need to write down the A value. So when the x cannot be A, which means, if you look at the question over here, the numerator is positive 4. The denominator can be any values. But then we know that denominator cannot be 0. Okay, then from here, your x cannot be 7 over 2. Which means, when you compare these two, x cannot be A and x cannot be 7 over 2. Which means your A is basically 7 over 2. So that is the solution for E. Now F. Find the composite function for GF. Okay, so now I will rewrite my fx first. So my fx is square root x minus 4 plus 2. Then my gx is 4 over 2x minus 7. So then now you are asked to get the composite function of GF. GF means you replace the fx by, you replace the x in your g by fx. Okay, you plug in this. Right? That means I will write, okay, or g of square root x minus 4 plus 2. This is my fx. And now what to do here is you change, okay, this x will be replaced by all this. So here will be changed. So what I need to do now here is it will be 4 over 2. Now the x will be replaced by these two terms. Then minus 7. So here it will be 4 over, now you do expansion. So you will be getting 2 square root x minus 4. 2 times 2 is 4. 4 minus 7 minus 3. So this is your GF. Alright, so done for the F. Now, the next one is state the reason whether the composite function fg exists or not. Just now we found the GF, now fg. Okay, E, F, G. So FG. Alright. So for this FG, check the condition of the existence of composite function. So I need to find out the domain G, right? So I need to find out the range G. So I rewrite my G's first. My G is 4 over 2x minus 7, whereby the x is real number and x cannot be 7 over 2. Okay, so from here, if I sketch a graph, right, 2x minus 7. So now, by referring to 1 over x graph, this is y equals 1 over x. Here is x, 0, y. Now, we know that x cannot be 7 over 2 if I need to sketch this graph. So what to do here is, I will change it into, instead of cannot be 0, because when you look at here, it will not touch 0. So now cannot be 7 over 2. So let's say this is 7 over 2. So, and then when you compare, this is positive, here is positive, right? That means it will be having the same shape. So my graph becomes this. So this is y equals to 4 over 2x minus 7. Alright, so then from here, I know that to get the range, okay, range of G, range is actually the y values. So the graph can be any values up to positive infinity and negative infinity, but it cannot touching the x-axis. That means now here I will say my gx is real number, but gx cannot be 0. This is my range of G. And at the same time, I need to check what is my domain F. Okay, so my domain F, let's check. Domain F, okay, we have found the domain F is basically this result. X is real number, but then x is greater or equal to 4. So now from here, I will write x is real number, but x is greater or equal to 4. So from here, I notice that the range of G, not whole range of G, is included in the domain F, because your domain F is just 4 onwards, but then the range of G can be negative value based on the graph, okay, and less than 4. So I will write range of G is not subset of domain F. Therefore, FGX does not exist. Okay, so this is the explanation for the composite function. Okay, so you have to check the range of the inner function and the domain of the outer function. Alright, so that's all for this video. Thanks for watching. Please subscribe to the channel and share this channel with your friends if you enjoy watching my video, and stay tuned for more upcoming videos. Thank you everyone. Bye.